Welcome back after the break. We were busy discussing the graded and ungraded profiles of a longitudinal river, profile of a river. Now, as you can see, we continue with an ungraded river. As you can see, there's nick points over there due to increase of velocity, volume of water, and maybe because of upliftment of land. And as you can see over here, we got a temporary base level of erosion. Now keep in mind, your ultimate base level of erosion will always be where the mouth of the river is, because the river can't erode any further than where the ocean is. Now our next topic is river capture. It's also known as stream piracy. It's basically, literally, like the name indicates, it captures something. And if you know what a pirate is, what does a pirate do? It steals other ships. Now in this case, is when one river steals water from another river. Now the reason why this happens is because this river might be rejuvenated. Because this river has got more power because of more volume of water. Now, as this takes place, there's a special type of erosion taking place, and it's known as headward erosion. We also refer to as backward erosion, because this whole, as the river flows, it erodes backwards into the watershed. And what it basically does, it erodes this watershed. Now keep in mind, what's a watershed again? It separates two drainage basins. It erodes this watershed and steals the water from another river. Now, it happens when two rivers run side by side and is separated by a watershed. Now, like I've mentioned, the one river erodes backwards into the watershed because it might have been rejuvenated. It might have been that the river is in a higher rainfall area. It might be because the rocks that it runs over are more prone to erosion than the less powerful stream. And then the strong river steals the water from the less stronger river. Now, in order for this to happen, I'm going to draw you a couple of diagrams. I'm going to draw one from a synoptic point of view. Now, I'm going to call this river A and this river B. Now, as you can see, let's say river A is rejuvenated. It means, like we looked at it, it gained more energy. And how does it gain more energy? By getting more water. Now, in the previous slide, we looked at a watershed. Now, a watershed separates one drainage basin from another. So we got river A flowing there with much more water than river B. Let's make this a small, as you can see, the stream is not as wide as this. So basically what happened, but very important, is this river's got much more energy because it's got greater volume of water. And what it starts to do, it starts to erode into this watershed. Now what is a watershed? It's the high-lying area that separates two drainage basins from one another. Because of the strong volume of water, great volume of water, it's got more erosional capabilities. There's more lateral erosion taking place. There's more vertical erosion that's taking place. So it starts to erode into this watershed. Now eventually when it erodes straight through to river B. But before I'm going to continue with this, let's just quickly draw a transverse profile. Now I've mentioned this is river A and this is river B. Transverse profile is a side profile. Now what it basically looks like, there you got river A. As you can see, the riverbed is much higher. And then we have our watershed that separates River A from River B. And then we got River B situated over there. Do you see the riverbed is much wider at River A than River B? And what makes it easier for this headward erosion to take place, River A is usually at a lower altitude than River B. So it's easier to steal the water from River B, because have you ever seen water flowing upstream? No, it's impossible. So this River A erodes straight through this watershed, through headward erosion. And then this becomes the captured stream, and River A becomes the pirate stream. Now, if we quickly look at this diagram over here, there's River A flowing over there. There's River A flowing over there. Now, what's happening over here? We say headward erosion is taking place. Pay attention. Do you see River B is at a higher altitude? Look here. Than River A. Now keep in mind, we say River A is rejuvenated. It's got more volume of water. Look at River B. It's just a small blue line. It means what I'm trying to indicate over here, not much water in River B. So backwards erosion takes place. This area over here is the watershed, separating the two from one another. The River A erodes straight through. Instead of River B continuing, what's happening now? It's flowing at a lower altitude to a lower altitude straight into River A. Now please bear in mind, there's a couple of characteristics that you need to pay attention. This is River A. It says the pirate stream. River B is the captured stream. And then where the river eventually don't flow, where it dries up, is the wind gap. And as you can see, the river starts to bend over here. See that? That's known as the elbow, stream elbow. And eventually what's going to happen with the stream, because it gets another source of water, this is known as the misfit stream. Okay, now let's just quickly go over this process again. River A has got a greater volume of water because it's been rejuvenated. It had a lower altitude. Backwards erosion taking place, headward erosion taking place. It starts to erode right through the watershed. It cuts through to River B that's got less volume of water. River B is higher than the River A. So obviously, because of altitude, because of gradient, because of Newton, the water is going to flow into River A. And then couple of characteristics develop. There's a wind gap, there's a misfit stream, and River B becomes the captor stream and River A the pirate stream. Now if you look at the next slide, once again from a synoptic point of view, a beautiful example. Look at River A. It's a thick blue line. That's the watershed separating two rivers from one another. Do you see they're running parallel with one another? This is the headward erosion taking place, cutting through the watershed. Eventually it will cut straight through. Now, as you can see, River B is just flowing its normal course. But look at that. It's a thin line against this thick black line on the other side. It will cut straight through, and look at the characteristics what develop. The bend is known as the elbow of capture. The area where the water completely dries up is known as the wind gap. And the misfit stream that eventually will dry up because it doesn't get any source of water becomes the misfit stream, and river A is known as the captor, the pirate stream, and stream B is known as the victim stream. Now, this is just the explanation of all of them. The captor river is the one that's energetic. This is the one that might have been rejuvenated, and that's the one taking the water from the other one. Also call it the pirate stream. The captured river, also known as the victim stream, is where the water has been intercepted. The misfit stream is a stream that follows eventually, is this one over there, that it will eventually dries up. Okay. And the elbow of capture, that's where the direction of flow taking place, where basically the bend is. The wind gap is where the water stops flowing and it basically dries up. And the waterfall that may form over there, in this area over there. Because we already discussed that stream A might be at a lower altitude than stream B. And a waterfall may develop. Now, coming to the end of our geomorphology section, it's quite important to look after our water resources. Many scientists believe that the next world war will be regarding clean drinking water. Now, keep in mind, yes, if you look at the hydrological cycle, it's a continuous cycle, but the thing is, if we don't manage our water properly, there won't be enough for the growing population of the world. Now, keep in mind, we need this water just not only for us to survive, but also to produce food. Now, unfortunately, if you look at South Africa, we've got most of the resources in the world. It's absolutely fantastic. I mean, we've got gold, platinum, and all of that, but unfortunately, we lack water, and we really need to look after our water resources because we need it for irrigation purposes, to farm, to feed the population, and obviously to survive ourselves. But in case we do have the water resources, we need to look after it. We need to be sustainable with it. Now, our river sources, our river systems are basically a resource. And the biggest problem in South Africa is we don't preserve our resources. And it's something that we need to share. I mean, we've got the Lesotho Highlands Water Project helping South Africa out to get more fresh water, drinking water for the Gauteng province. And in this case, when we do get this water in the form of precipitation or from other countries, like the Lesotho Highlands Water Project, we need to be able to preserve it and to look after it. Now, water is essential, like I've mentioned, and we can't grow economically and we can't develop in a developed country if we do not look after our water resources. Now, if you look at it, what do we use our water resources for? Agricultural activities, industries, domestic use, that's me using it to bath. We can use it for hydroelectric power. Now, hydroelectric power basically to generate electricity from it, and we can use it for recreation, going to the dam to relax, boat rides, etc. Now, I want to continue, if you look at it, very importantly, if you look at the impact that we have on these drainage basins. And unfortunately, over the years, the human influence is not great. We tend to pollute our rivers. We then tend to not use our water correctly and sparingly. If you look at the situation in Cape Town, it's quite dire because of the drought and because of the human consumption and because not using the water correctly. They might end up with no water by the end of January. But very importantly, with our mining activities and agricultural activities, pollution takes place on a regular basis. Industries tend to pollute the Vaal River. For instance, around the Vaal River area are mining industries in the Northwest Province. And the agricultural sector tend to use too much fertilizers on their products. Now, a great example is the Hartbeespoort Dam. Now, if we will look at the situation at the Hartbeespoort Dam, the water is green and it's basically unusable for recreational use, and basically the water is rotten. And because of the process of eutrophication, the water is completely green and covered in algae, because what happens is our farmers are using too many fertilizers on their crops. And because of sewage that's being dumped into this dam, what happens? These fertilizers makes the algae grow even faster. Now, as you know, if you're a life science student, algae is a plant. So what does it do? It starts to remove the oxygen from the water. Now, unfortunately, what does this algae do? It removes all the oxygen from the water, and the water starts to rot. The ecosystem around the dam, inside the dam, it's been destroyed. And it's going to take quite a few years to try and solve this ecological disaster. Now, our industries and mining companies are also guilty of polluting our river systems. And what can we do as a community? Basically, the government should fine these companies that pollute our river systems. The government should fine these farmers for their runoff of using too much fertilizers in their products and crops. And we need to basically come up with suggestions. How can we preserve our ecosystems and our river basins? Now, very importantly, not only is the companies guilty of polluting the rivers, but also domestic use. Now, unfortunately, in many informal settlements, because they lack the basic needs and services, they rely on these rivers to wash their daily clothing, etc. So it's up to the government to provide these communities with basic needs and services so they don't need to pollute our river systems any further. And once again, we need to go and look at the type of vegetation. Unfortunately, South Africa is covered in a lot of alien vegetation. What does alien vegetation mean? It means it's plants that's not originally from South Africa. It's trees that's not originally from South Africa. And sometimes these plants use more water than they actually should. So we should actually remove that and plant indigenous plants that's actually accustomed to South Africa's climate. Boreholes might be a problem because we basically use the water table. We reduce the amount of water in the water table. That's a great concern as well. So we need to find different solutions to preserve water. Maybe build dams, or like we've done with the Lesotho Highlands Water Project, trade and conserve our waters in a much better way. In the next lesson, we're going to look at settlement. Thank you for watching. Looking forward to see you again.